2.7, using absolute value functions and transformations. Okay, we are going to talk about a lot of different graphs this year, and I'm going to use the term parent function a lot. Okay, that's what you're going to have to get used to. So a parent function is the basic function of that graph, the most simple version, the most watered down version of that graph. Here, this is an absolute value parent function. The function of x equals the absolute value of x. I can replace this f of x with a y. Okay, remember we talked about that before, how you can plug a y there and it's the same thing. Okay, the way you're going to see it written though is the function of x equals the absolute value of x. When you have an absolute value graph, you should always have a v, period. If you don't have a v, you have done something wrong. Okay, whether that v is facing up or down, you have a v. Okay, the reason you have that is because in absolute value, if I put a 2 into the absolute value sign, what do you get out if you say the absolute value of 2? 2. What do you get out if you say the absolute value of negative 2?
2.
So that's why you have a v, because it always mirrors what happens. Okay, because you have a positive and a negative input for the same output. In a standard parent function of absolute value, your graph always starts at 0, 0. If I input a 1 to here, okay, I get a 1 out. If I input a negative 1 there, I get a 1 out. If I put a 2 in, I get a 2 out. If I put in a negative 2, I get a 2 out. That is the parent function of this graph, okay? In the parent function, the vertex always starts at 0, 0. The vertex is the highest or the lowest point on the graph because it's your point where both of those rays come together to make your V. So it's the highest or the lowest point. We're going to talk about what makes something a low point. Questions on the parent function yet? On your homework, they're going to ask you to compare the graphs that you're graphing with the parent function. I suggest using 2 colors. One for your parent function, one for your graph. I suggest doing your graph in pencil and the parent function in pen because the parent function doesn't change and you should be able to get used to that. You know what I'm saying? You should be able to say, okay, the parent function is 0, 1, 1, negative 1, 1, negative 2, 2, and 2, 2, and you can graph that every time. And then you can visualize it and then put it into words of how it compares. The parent function is 4 units to the right of the new function that I create, or whatever, okay? So we're going to talk about that. So when you have absolute value, you have a parent function that looks just like that. Now, you can have transformations and translations that happen to any graph. A transformation, which you should have talked about transformations and translations in geometry. I know you did. I know you did because I just taught it in geometry. Okay, so transformations change the graph size, shape, position, or orientation. So it's going to make the graph larger, smaller. It's going to change where it's located, and it's going to change its orientation. That's when you have similar triangles or similar things going on. A translation is a transformation that shifts a graph horizontally and or vertically. So it's going to shift it up and down, left and right, okay? But it does not change its shape, size, or orientation. A transformation changes the size, the shape, the orientation, okay? One of those or all 3. A translation shifts it, left, right, up, down, okay? So if a translation is happening, my graph doesn't become skinnier or wider. It stays the same width as this parent function. It just would shift left and right or up and down or both. A transformation is going to make this parent function skinnier or wider, or it might flip it, okay? We're going to graph 1 and compare it to the parent function. We might graph a second one after we talk about this other stuff too. So, give you a second because you're still writing all that. And it's important to know those definitions and key terms. Transformation, translation. Those should be words that are in your vocabulary already. If not, let's make them part of your vocabulary. Okay, Jason?
I do remember that.
Good. I'm glad you at least remember that you've heard those before. That is a start in the right direction. Okay? Transformation changes the graph size, shape, position, or orientation. The translation is a transformation that shifts a graph horizontally and or vertically, but does not change its size, shape, or orientation. Okay. So then it says, let's graph this. Okay, this right here, y equals the absolute value of x minus h plus k. This is going to be your standard form of an absolute value equation. Okay, it's our standard form. So basically what I did is, remember this is the parent function, the simplest form. This is my standard form. This h and this k tell me things. Okay, the h and the k are my vertex. Now look, in this graph here, do you see how this says x minus h? Do you see how this vertex says positive h? Okay? The vertex, the h is always opposite of whatever sign is there. Okay? H is opposite of what it is in the absolute value. If people mess things up, that's the thing they mess up the most. Okay? Your h is always opposite. Now, your k, see how your k is positive here? And your k is still positive here. The k stays the same. The h is opposite of what it is in the absolute value. Because if you take the absolute value of h, what do you get? You get the opposite, right? When I'm taking the absolute value, so then I'm getting the opposite there. Okay? So my graph, it wants me to graph this equation and compare it to the parent function. So my graph is y equals absolute value of x plus 4 minus 2. When you go to graph this, okay, when you go to graph this, step 1, we want to find the vertex. What is the vertex of this equation right there?
-2.
And?
4. Or x plus 4.
No. Your vertex is your opposite of h and your k. My h is?
4.
So what's the opposite of 4?
-4.
Good. -4. And my k is? -2. So my vertex is -4, -2. I start by graphing -4, -2. So find the vertex. Number 2, graph vertex. Okay. So I go to -4, -2. That's my vertex. Okay. Step 3. Plug in a point. Or x to get y. Okay? Here's what I suggest. If your vertex is at -4, -2, your x is -4, plug in the point to the right or to the left of it to make your life easier. I'm going to plug in -3. Okay? So I'm going to take this equation and I'm going to say y equals the absolute value of -3 plus 4 minus 2. What is -3 plus 4?
1.
So y equals the absolute value of 1 minus 2. What is the absolute value of 1?
1.
So then y equals 1 minus 2. What is 1 minus 2?
-1.
-1. So your point was, you plugged in -3. Your point is -3, -1.
Oh.
You are going to graph -3, -1. Okay, so step 4 is graph this point. And then step 5 is reflect that point. Over the axis of symmetry. Okay, so you're going to reflect that point over the axis of symmetry. Where's the axis of symmetry, you ask? Well, good question. The axis of symmetry goes straight through your vertex. Makes it easy. So I reflect this point over my vertex. Now do you see why I chose a point very close to the vertex? So I don't have to mess up and count the wrong way or screw something up. Okay? And then step 6, the last step, connect the dots to form a V. Okay, now I have done one step. I have graphed that equation. They also wants me to compare it to the parent function. So when I compare it, I graph the parent function. Where does my parent function always start? Where's the vertex of my parent function? 0, 0. When you plug in 1, you get 1 out. When you plug in -1, you get 1 out. So it's very easy to graph this. Now, I need to compare it in picture form like that. Okay. I need to compare it in words. How does this vary from the parent function? What happened to it? What did we do to it?
It slid over 4.
Over
To the
4
left.
to the left and
Down 2.
okay.
Slid is the right word, right?
You can say that, yes. Okay. The new graph is 4 to the left and down 2 compared to the parent function. So on your homework, when it asks you to compare something to the parent function, I want the parent function graphed on there and I want it in words. Okay? I want to know that you know what is happening. Because we're going to get into harder ones, so I need you to understand how this is working so that we can do the harder ones later. Okay, I'm going to introduce this and then we're going to graph one more and then we're going to do some homework. Okay, this says if your A in the absolute value, okay, the absolute value of A is greater than 1. Here's where A is. Let's talk about this. I can stick an A on the outside of this equation right here. Okay? The A is my scale factor. Okay? You know how when we did y equals A times x? Okay? And that A was my scale factor? Same thing in this graph. My A is my scale factor. If the absolute value of A is greater than 1, the graph is vertically stretching. So, if the number is 2, 3, 1.5, I am stretching this graph and making it skinnier. Okay? Think about, I always tell them, when you are tall, you're stretched, right? Like a lot of people that are tall and skinny, they're stretched out. Okay? So they're taller than us, they have bigger numbers than us. That's how you think of it. Now, the graph y equals A, absolute value of x, is narrower than the graph y equals x, the absolute value of x. Because when you have a number that is stretching it, you get narrow, okay? If the absolute value of A, if this number here, when you take the absolute value of A, is less than 1, if it is a fraction, if it is a negative number, no, if it's a fraction, because you're taking the absolute value. If it's a fraction, 1/2, 3/4, whatever, a decimal, 0.68, the graph is vertically shrunk or compressed, so it's going to compound and get short and fat, okay? So this graph is going to come here and get short and fatter, wider, okay? So the graph of y equals a, the absolute value of x, is wider than the graph of y equals the absolute value of x. So we're going to look at two of those, and then we're going to move on from there. Okay, so let's graph this. We're going to graph three things on the same one. Y equals 1/2 the absolute value of x. We're going to graph y equals -3 the absolute value of x. And then we're going to graph the parent function of y equals the absolute value of x. We're going to talk about how all these compare, okay? So we're going to start with some simple ones. Okay, let's graph the first one, the pink one. Y equals 1/2 absolute value of x. How do we graph? What's the first thing we have to find? Find the vertex. What is the vertex of this? Do I have an H? Do I have a K? So what would my vertex be? 0, 0. Okay. Drew is right. There is no vertex, so it's 0, 0 is my vertex. Okay, so here's where I'm graphing. Step 2 is graph that point. Step 3 is plug in a point for x to get y. Okay? Step 3, I'm plugging in a point. Now, remember I told you let's plug in a point that's next to that vertex. So we're going to plug in 1 to make our life easy. So I'm going to have y equals 1/2 times the absolute value of 1, right? What is the absolute value of 1?
1.
So what is 1 times 1/2? So my point is 1 and 1/2. Here's 1, here's a half. Now, step 4 is reflect, or that is step 4 is graph. Step 5 is reflect that point, right? Where's the axis of symmetry go through? The vertex. So I reflect this point. And then step 6 is connect the dots, right? So here is the graph of that one. Okay, now let's graph y equals -3 absolute value of x. Step 1, find my vertex. What is my vertex on this one? 0, 0 again. Step 2, graph the vertex. So I graph 0, 0. Step 3, plug in a point, right? Y equals -3. I'm going to plug in 1 again because it's easy. Absolute value of 1 is 1. 1 times -3 is, so my point is 1, -3. Graph that, right? Graph 1, -3. Step 5, reflect. So my axis of symmetry is still through 0, 0. I reflect this point. And step 6 is connect the dots. Okay?
This is why you want us to use different colors.
This is why I want you to use different colors. Makes sense now, Jason? And then the parent function. Parent function, I don't even really need to go through these steps because I should be able to just memorize that eventually, okay? Here's my graph of my parent function. Now we're going to compare, okay? So, how does the pink graph compare to the parent function? What is happening to the pink graph compared to this brown graph?
It's wider.
It's wider, good. The pink graph is wider than the parent function. Okay, and it's wider than the parent function by how much? Where can I just?
By half.
By a half. Good. And that's how I compare that graph. Now, what's happening to the green graph?
It's vertically stretched.
It's vertically stretched, and what happened to it? It's flipped, right? You're right, it's reflected, it's flipped. What makes it flip down, do you think? The negative. This negative will always make a graph flip. Okay? That's how you know if it flips. Green graph is flipped and stretched. And what is it stretched by? By 3 units. And that's how I'm going to compare those graphs.
We have to say units or like.
No, you can just say by 3 by 1. That is what you are going to do tonight.